In this video, I'm going to be going through the Year 11 or Preliminary Engineering Studies, Chapter 1, and we're looking at materials. We're on M8 Composites. So, composites are made from mixed materials. Timber can be classified as a natural composite material or a combination of materials. In this case, cellulose fibers and lignin resin. And that's usually the case that for most composites, there's usually fibers or aggregates, but usually fibers, and they're held together in a binder or a resin, or sometimes called a matrix. So that's true for carbon fiber. That's true for fiberglass. It's in the case of ceramic, instead of it being fibers, though there are often steel reinforcement which acts as fibers, but it's in this case it's also aggregates. Okay. So, engineered timbers include plywood and other engineered timbers such as LVL and glulam. So we can see LVL is this one here. It looks like plywood, but it's long beams of it. The idea is that you take strips of timber and you can just stick it together and you can join them as needed. And so you can make pretty much a beam of infinite length if you had to. You could just keep sticking together sheets. It's pretty good. It has pretty good strength properties. The alternative is you could just use glulam, right? It's not as highly engineered. What it does is you just take bits of timber. You take what would otherwise be a stick of timber, and you just stick them together. And you can again have that brickwork pattern. If you don't have, let's say you want to make a 9 meter board, it's pretty hard to find a tree these days that you can cut down that will give you a 9 meter length of timber. So instead you can use glulam to join those pieces together. What are the other advantages? Well, they usually have higher strength, not because the materials are better, though the glue does make it a little bit stronger. But also it's stronger because it's free from impurities or defects. It doesn't have knot holes. We can cut the knot holes out. We can make sure that all the timber is of the same consistent quality. It can be made to very long lengths. So I talked about how it's hard to buy 9 meter length of timber anymore. And it can be cut. It can be designed into specialty shapes. So you can make it into curves or waves. And so some architects go out of their way to make very interesting shapes out of these engineered materials. Okay. So that's timber. We can now move on to the next one, which is concrete. Concrete is a composite of cement and aggregates, and the aggregates are sand and rocks. Okay. I think basalt is the most commonly used, or at least in Sydney, I think basalt is used. I think because we have a lot of basalt in the Sydney Basin, or the St. George, yeah. Yeah. So I think we use a lot of basalt, but it can be other things. It can be granite, it can be other stuff. Reinforced concrete uses steel reinforcement as it provides the tensile strength. Now, we're going to talk about concrete cancer. So concrete cancer is where you don't have sufficient concrete cover to the reinforcement. Now, how do you know if you need, or how much cover you need? Well, it depends on how well the concrete is going to be vibrated, right? How well it's going to be, the defects are going to be removed by shaking the concrete, or compacting the concrete. The other thing is that we care about the strength of the concrete. So if we're in a very marine environment, if we're like building a house on the waterfront, well, we would use a large amount of concrete between the outside edge of the concrete and the steel, and we'd use very high concrete, and we might even use stainless steel reinforcement, which is incredibly expensive. But if you're within, I don't know, 100 meters of the water, you probably want to consider that, because it does say in the concrete code how you design for that based on where you live and your proximity to the ocean. Why is concrete cancer such a problem? Well, the thing is, once you get rust in the steel, we know that rust spreads. Yeah, the rust molecule is bigger than the steel molecule, so as it rusts, it's going to expand. And when it expands, it's going to put pressure that causes the concrete to crack. As more and more steel expands and rusts, more and more of it's going to crack and expand, pushing out, continuing to break away more concrete, exposing more steel. So it spreads, and this is where we get the term concrete cancer. More technically, we use the term concrete spalling, but concrete cancer is very commonly used. It's incredibly expensive and difficult to repair. Okay, so lastly, we're going to talk about fiber reinforced polymers and FMLs. So fiberglass is an example of a polymer resin with glass fibers. Carbon fiber reinforced polymers are increasingly used in racing and in aviation, flights. Yeah. So I've got the example of the Boeing 787 uses a lot of carbon fiber. Fiber metal laminates such as glare, Glare, was used in the Airbus A380s, and it has advantages over aluminium such as lower weight or lower density and better resistance to fatigue, corrosion, and fire. Now, we've talked before about durability. How I used to say the word durability is material's ability to withstand erosion, corrosion, fatigue, and fire. But these days, I would say, from doing HSC marking, we really shouldn't say durability. The same way we shouldn't really say strength. We should specify what kind of strength. We should specify what kind of durability. We should say corrosion resistance, resistance to wear, resistance to corrosion. Okay, so I've got 3 questions, and then we're finished with materials. What are the benefits of engineered timbers? Stronger, free of defects, longer. Yep, interesting shapes, yep. Okay, define aggregates in relation to concrete. Yeah, they make up the bulk of the weight of concrete, but they include sand and rocks. Yeah. They do give concrete strength. So the cement content does make a difference, but concrete performs much better than just pure cement does. So even though they work in combination to work together, you can just make pure cement, but it doesn't perform nearly as well. Okay. Identify 2 applications for carbon fiber reinforced polymers. Where do we use carbon fiber? Okay, we use it in aviation and we use it in racing. Give me an example in racing. F1 and bicycles, right? So like, in cycling, yeah? Oh, like the entire frame of the bike might be made of carbon fiber these days. Hockey sticks these days can be made out of carbon fiber as well. Okay, so there are an enormous number of applications. The chassis for motorbikes often made out of carbon fiber as well.